All right, today we will continue on with angles in a triangle. We have a fairly short amount of notes, and then after that, you'll have a worksheet. As far as upcoming stuff goes, we will have a quiz on angles of triangles, which is the stuff we've been doing the last couple of days, on Wednesday of this week. So, here's an example of a problem that we haven't done before. It's not a difficult problem, but we just haven't done one like it, so I wanted to make sure we did because it is on your homework. Given the measures of two angles of a triangle, find the measure of the third angle and classify the angle as acute, right, or obtuse. Now, just before we jump into this problem, let me point out to you that I could have cut out all this part in the middle and you still would have had to done exactly the same amount of work. Because you can't tell what type of triangle you have until you know the measures of all three angles. If you don't know the measures of all three angles, you don't know what type of triangle it is yet. Okay, so I've gone ahead and done the first one for you. We know that the measures of two of the angles are 37 and 28. We add those together, subtract from 180, and we get 115. If that's 115, then this is an obtuse angle. So that's an obtuse triangle. The two that I'm going to give you are always going to be acute. You're always going to have to find the third angle. So the first two are acute, 49 and 62. If we add those together, that's 111. If we subtract that from 180, we get that this is 69 degrees, so the third angle is 69. So since all of the angles are acute, what kind of a triangle is this? It's an acute triangle. And then for this last example in this section, we've got 72. Cole, go put it back. No, stand up and put it back. So 72 plus 18 is 90. Now on this one, as soon as those two acute angles add up to 90, what's the other angle going to have to be? It's going to have to be 90. I can actually do the work if you want, but it's going to be 90. So what kind of a triangle is this? It's a right triangle. Okay, are there any questions about that type of problem? Pretty straightforward, right? Okay, let's go on to the back then. And let's do some problems where you're giving a fairly complex diagram and then asked to find several things. A couple things to point out to you here. Number one, you don't have to do them in order. Okay? On this first one, we can, and so I will, but you don't have to do them in order. Okay? Second thing is, don't just look at little triangles. Look at big triangles also. For example, if I'm trying to find angle A, if I try to use this little triangle right over here, I got to find angle B and I got to find angle C before I can find angle A. But if you look a little bigger and look at the triangle that has these three vertices, I can go directly to finding angle A. Because I know this angle is 40 and this one's 71, I can just add those two and subtract from 180. So 40 plus 71. So 111, oh, we just had that a minute ago. 180 minus 111 was 69. Then we're looking for B. B is something from earlier. How can I find B quickly? You know what to do, but you're saying it backwards. Do what now? Okay, subtract 133 from 180. So 180 minus 133 is 47 degrees. Now, at this point, there is a fast way to find angle C and there is a slower way. The slower way is not wrong, it's just slower. And you're more likely to make a mistake. One way to do it, and this would be the slow way, would be to add these two together, subtract from 180 to find this angle, and then subtract that from 180 to find angle C. It's a complete waste of time, but you can do it if you really like. What is the faster way to find angle C? No, there's no parallel line, so we can't use alternate interior or any of those other things.
Two interior angles equals to one exterior angle.
Yeah, the exterior angle is equal to the sum of the two remote interiors. So all I have to do to find this angle that's labeled C is add 69 and 47, and I'm done. That's 116, and that's angle C. Likewise, in the reverse order, I can find angle D in a single step. I could find this angle first and then do the angles of the triangle, which is fine. There's nothing wrong with that. But there's a faster way. Does anyone see how I could find D more quickly? Yes?
140 minus 47.
Yes. So in this triangle, the 140 is an exterior angle. So the exterior angle is equal to the sum of the two remote interiors. So that means to find D, I just need to take 140 minus 47. That leaves 93 for D. Now, for finding angle E, you're going to have to find some other stuff first. I don't see any quick and easy way to find E. So, since we're already over here close to it, if this angle is 93, how much is this angle? 93. What kind of angles are those? Vertical angles. Those are not going to go away. And then let's see, if I went 93 plus 40, that's 133. So this exterior angle right here is 133. Remember, the exterior angle is equal to the sum of the two remote interiors, which means that this angle right here is 180 minus 133. Should be 47. And then from here, there's a fast way to find E and there's a slower way. The slower way would be to find that this angle was 47 and then do the angles of the triangle add up to 180. The faster way would be to look at this triangle, and the 133 out here is an exterior angle. So the exterior angle is equal to the sum of its two remote interior angles, specifically E and 47. So I just need to take 133 minus 47, and that's 86. So on a lot of these problems, using the exterior angles will make your life easier. You don't have to use it, but it does make things faster a lot of the time. All right, let's look at the second diagram. And I'll start in alphabetical order, but I may abandon it later. Is there a way I can find M? There are two different ways. There's a fast way and a slower way. Give me one of them, please. Yes.
60 plus 90 minus 180. Sorry, 180 minus 60 plus 90.
Okay, that would be the slower way. What's the faster way? Yes.
90 minus 60.
Yes. Remember that in a right triangle, the two acute angles have to add up to 90. So if I just did 90 minus 60, that's 30. And again, it's not wrong if you do it by adding the 90 and the 60, subtracting from 180, but it just takes a little bit longer. All right, now I'm going to try and find N, which is the same size as this angle right here. What's the quick way to find this? Yes.
90 minus 40.
Yeah, if you take 90 minus 40, we get this angle's 50, so N is also 50. Well, once we get to P, there's not a super fast way to find that. Although I know that this angle is 30, and angle P is the same size as this angle right here. How can I find this angle quickly? Yeah, just do 112 minus 30. And that's 82, so P is also 82. So far, we've been doing these all in one step. When we get to Q, that all ends. But it doesn't take a lot of time. If this angle is 70, so is this one. So I can do 82 plus 70. It's 152. And then subtract that from 180. And that gives me that Q is 28. From there, I'm going to find S before I find R because I see a way that I can find S immediately, one step. Yep.
Oh, never mind.
Okay. And it's not 70. This 70 is up here, not down here. It's a poor placement in this diagram. It should be a little higher up. There's no parallel lines, though. Yes.
Is it, what's it called? Same, no, corresponding angles with the right angle next to you?
Well, there's no parallel lines, so corresponding angles isn't going to be helpful to us here.
90 degrees.
No, it's not 90. Okay, look at the triangle that has a vertex here, and here, and here. Do you see how S is an exterior angle for that triangle? So I can do 50 plus 28 is 78. This angle has a measure of 78. So if this is 78, I can use that to help me find R. 70 plus 78 is 148 from 180. It's 32. So R is also 32. Lots of vertical angles in this. All right, angle T, students can get lost on that because they just look at this little figure here in the middle. Don't just look at that one. Look at, let me mark it with a different color, this triangle. Do we know two of those three angles?
Yeah.
Yep. So 30 plus 32 is 62 from 180. Thank you, 118. I'm sorry?
What S?
Go ahead, Liam.
Oh, why didn't you do so on the triangle to the left of it, I put 112 plus 50, and I got 162, subtract 180 from that, and then, like,
To get this angle? You can. Yeah, there's frequently more than one right way to do this. By the way, the faster way to find this angle is to do, wait a minute. No, you can't find this angle that way. What you can do is do 112 minus 50, because the exterior angle is equal to the sum of the two remote interiors, and that would give you that this was 62, and then subtract that from 180 because you've got a linear pair. That would work. Where are we to now? We're all the way down to U. Let's see, I need to fill in my chart up here. R was 32. S was, where is S? 78, thank you. And then T we just found was 118. How can we find this angle right here very quickly?
So 180 minus 180.
180 minus what?
78.
Well, the three angles in the triangle have to add up to 180, so not so much.
I mean 118 minus 78.
Oh, 118 minus 78. Okay, I thought you said 180.
I did.
Okay,
He changed his answer like 3 times.
so this is 40, which means this is 40. And then how can I quickly find U? Yes, sir.
Would 40 be the outside angle and add up? So
No, this is not exterior to the triangle. The exterior angle has to be right up against the triangle.
I'd probably say 90 plus 40, 180 minus the sum of 40.
Okay, and that's fine. You can do it that way. There is a faster way, though. Yes? Yeah, if you just do 90 minus 40. That angle right there is 50. Because in a right triangle, the two acute angles, Cole, you with me? In a right triangle, the two acute angles add up to 90. Okay? All right. I have a worksheet for you, and I'll let you go ahead and get started on that.